Today we are starting our unit on graphing exponential functions. So we're going to be looking at the key attributes of these exponential functions and their transformations. So there's a couple of words here at the top that you just need to be aware of, like asymptote, the decay factor, the growth factor, what an exponential function is, and all of that. So if you want to go through and read those vocabulary words, it is just their formal definitions. So here we see that we can either have a function that is growing or a function that is decaying. If we have a function that is decaying, then our b value, the base, is going to be a fraction. So we see that here. Decay is going to be a b value that is a fraction, and then growing is going to be a b value that is greater than 1. So anything that is larger than 1, anything that is not a fraction less than 1, is going to be growing. Here we have the explanation of all of our transformations that can occur on an exponential function. So an a value, something in front of the base, is going to stretch or compress or reflect. So we know the reflections come from negatives, stretches are going to come from whole numbers, and compressions are going to come from fractions. B is going to be our base every single time. A horizontal shift, either left or right, is going to be occurring inside that exponent. So if it's minus, we're moving to the right. If it is plus, we're moving to the left. So remember the opposites with our horizontals. And then vertical shift is going to be the same as always. It's going to be that plus k value on the end there. And then in order to find the equation of our asymptote, we're going to look at whatever that plus or minus value is on the end there. That's going to be our equation for the vertical asymptote. Not vertical, sorry, horizontal asymptote. It's going to be y equals whatever that number, that value is. So the parent function will be f of x, or y equals b to the x, where b is any base that isn't 1. Here we've got a little bit more explanation on those transformations. So we're going to start with number 1. On number 1, we've got this function y equals 2 to the power of x minus 5. So our parent function is y equals same base, 2 to the power of x. Now our parent function, I'm going to make a table for it. If I had 0 for x, then we're taking 2 to the power of 0, which is 1. If I had 1, we're taking 2 to the power of 1, which would give me 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. So we can see how that can grow rapidly. So as we're going from 1 to 2 to 4, then jumping to 8 to 16 to 32 and so on. So that's the parent function. But we're taking that parent function, we've got that minus 5 on the end, which we know will be a vertical shift down 5 units. So we're taking that parent function and shifting it down 5 units. The asymptote we get from y equals that last number, which is negative 5. The y-intercept we're going to get where x is 0. So we'll find that in our table here. If x is 0, we have 2 to the power of 0 minus 5. 2 to the power of 0 is 1, minus 5 is negative 4. Another way we can find those values is looking at our parent function and moving them 5 units down. So 1 goes to 2, move 2 5 units down, we're at negative 3. 2 goes to 4, move 4 5 units down, we're now at negative 1. So our y-intercept occurs at 0, negative 4. So we're going to draw in our asymptote. Down here, negative 5. Then we've got 0, negative 4, 1, negative 3, 2, negative 1. And we could go further. 3 would be at 8, but we're going to move 5 units down, so 3 is now going to be positive 3. So we're taking these points, connecting them. But this is not a square root function. It's not just going to stop at a value. So we're going to continue on the left side and get closer and closer to that asymptote. So now our domain is all real numbers. We're going to cover every single x value. And our range, our y values, will be every single y except anything below or equal to negative 5. So we'll start at negative 5 and head toward positive infinity, and we'll be able to cover every single value that is after negative 5. Now on number 2, we have a fraction. We've got 1/3, and then our exponent is x plus 2. So since we have this 1/3, we're going to have decay. So our function is not growing, it is getting smaller and smaller. And then the transformation that we have is happening in the plus 2, that is in the exponent. So we're going to move opposite. So this will be horizontal shift. Opposite of plus would be left 2 units. That's the only change that is occurring from our parent function of same base to the power of x. Now our asymptote will occur whatever that plus or minus value is at the end of the function. So we would have 1/3 x plus 2 plus or minus something, but since we don't have anything there, we stick with y equals 0, because this would be plus 0. Then we'll find the y-intercept, the domain, and the range by the table. So we'll start with 0, 1, and 2. If I plug in a 0, I have 1/3 to the power of 2. 1/3 squared is 1/9. Now if I'm taking it with x as 1, we have 1/3 to the power of 1 plus 2, so 1/3 to the power of 3. 1/3 cubed is 1/27. Then on 2, we would have 1/3 to the power of 2 plus 2, so 1/3 to the power of 4, which is 1/81. So we see that our values are getting smaller and smaller and smaller and closer to 0, but we're not getting to 0. That's because we're approaching our asymptote. So in order to find values that we can use with a graph like this, what we're going to do is move in the opposite direction. We're going to move toward negatives and see what happens. So I'm going to find x and y, -3, -2, and -1. So if I plug in a -1, I would have 1/3 to the power of -1 plus 2, which is 1/3 to the power of 1, which is 1/3. We'll do the same thing with -2. So we're taking 1/3 to the power of -2 plus 2, which is 1/3 to the power of 0. And anything to the power of 0 is 1. And then 1/3 to the power of -3 plus 2, which is 1/3 to the power of -1, which we know flips that fraction, so it's 3. So now we've got two whole values. Let's draw in our asymptote. Right, so we've got -3 is at 3, -2 is at 1, and -1 is at 1/3. And then every other value that we found is just getting infinitely closer to that asymptote. So our y-intercept we found 0, 1, 9. The domain is going to be all real numbers. And then our range, the y values can touch anything above 0 and nothing below 0. So our range goes from 0 not included toward infinity. Then the last example we have is y equals 2 to the power of x minus 1 plus 3. So my parent function is the same base, just to the power of x. So my parent function is y equals 2 to the x. And so we see that we have minus 1 and then plus 3 occurring. The minus 1 is inside the exponent. So inside the exponent is a horizontal shift in the opposite direction. So we're moving right 1 unit. And then that plus 3 on the end is going to be a vertical shift in that direction. So down, oh, not down, sorry, up, because it's plus 3 units. So those are my two transformations that are occurring on number 3. My asymptote is going to be y equals whatever that last value is, so 3. So I'm going to go ahead and graph the asymptote. So to find my values, I'm going to plug in my x's. So y would equal 2 to the power of 1 minus 1 plus 3. So y would equal 2 to the power of 0 plus 3. Anything to the 0 power is 1, so 1 plus 3, which is 4. Next one, y would equal 2 to the power of 2 minus 1 plus 3. 2 minus 1 is 1. 2 to the power of 1 is 2. So my value is 5. And then we'll plug in a 3. We get 2 to the power of 3 minus 1 plus 3. 2 to the power of 2 plus 3. 4 plus 3, which is 7. So at 1, we're at 4. 2, we're at 5. And then 3, we're at 7. And we're getting infinitely closer. Looks like I'm getting further away, but you get the point. We're getting infinitely closer to that asymptote. So my y-intercept would be where I have 0. So let's plug in a 0. Get 2 to the power of 0 minus 1 plus 3. 2 to the power of negative 1 plus 3, which is 1/2 plus 3, which is 7 over 2, or 3.5. So we've got 0 and 7 over 2. Domain is all real numbers. And the range, it can be any value for y except anything that is on 3 or below it. So we're going to go from 3 toward infinity. So we can see the difference in the graphs looking at 1, 2, and 3, that the only one that was facing the other direction is the one that is a decay. So our decays are going to look different from our growths, and we can see that from their graphs. Then for your homework portion, there are 10 problems for you to do, but I just want you to choose either evens or odds. So either you're doing 1, 3, 5, 7, 9, or you're doing 2, 4, 6, 8, 10. So you don't have to do all of them. You choose a side, stick to that side. So don't flip-flop back and forth. Just choose either I'm going to do all the evens or I'm going to do all the odds. The only difference in these compared to what we did is they have an a value. So just apply what we've learned and look at the notes and see what you can do with that A value in the front there. So you're turning in 5 graphs, sketch them on a separate sheet of paper, and then all of the key attributes that it's looking for. Then make sure you turn that in on Canvas, and I'll see you guys next time.